Welcome everyone to This Explainer. Okay, today we are embarking on a highly technical and honestly incredibly delicious mission. We're stepping completely out of the standard kitchen and diving straight into the culinary laboratory. Why? Because we're going to engineer a flawless, dual-concept junk food masterpiece. We're talking about the composite pizza burger engineering protocol. So if you've ever literally dreamed of fusing two of the greatest comfort foods known to humanity into one perfectly structurally sound unit, well, you are absolutely in the right place.
But here's the massive, high-stakes engineering question we really have to face. How do you actually build a pizza burger without a complete, catastrophic blowout? I mean, think about it for a second. You've got heavy, juicy meat, melted cheese, sauce, and bread, all fighting against each other. Most amateur attempts, they just result in a soggy structural disaster the exact second you take a bite. But not today. Today, we're going to solve the problem of structural and culinary integrity once and for all. Okay, let's dive into our blueprint for this. We'll start right off with the pizza burger protocol itself, then move into Phase 1, which tackles the turkey patty. After that, Phase 2, where we construct the non-matrix. Then we'll hit Phase 3 for architectural assembly. And finally, we'll wrap up by looking at exactly how to mitigate those catastrophic structural failures.
So, starting with Part 1, the pizza burger protocol. This is our blueprint for a true culinary marvel.
Our main objective here is to construct a highly satiating dual-concept meal. Specifically, we're talking about a lean turkey burger entirely encased within two mini, whole-grain turkey pepperoni naan-pizzas. It sounds crazy, right? But we actually have to treat this less like a recipe and more like a sophisticated architectural achievement. Every single ingredient you use has to serve a very specific structural purpose, right alongside its flavor purpose.
Moving into Phase I, the turkey patty, and how we go about counteracting thermodynamic moisture loss. Now, poultry is notoriously tricky because it dries out so easily under heat, and that brings us to an absolutely strict parameter for our primary protein. You must, and I mean must, use 93% lean organic ground turkey. Why? Well, that 93% lean ratio contains the exact fat matrix required for cohesion. If you try to cut corners and use 99% lean turkey, you are quite literally setting yourself up for failure. It just lacks the fat necessary to bind. The meat's going to crumble, and structural failure is practically imminent. But here's the thing. Fat alone isn't going to save that turkey from thermodynamic moisture loss. We need science. Specifically, we need a hydrocolloid. By grating just a quarter cup of organic yellow onion on a box grater, and this is vital, keeping absolutely all of its juice, we actually harness the onion's natural pectin in water. This creates a hydration matrix that physically locks the moisture inside the meat while it cooks. It's just a brilliant, totally natural way to scientifically prevent a totally dry burger.
Okay, so with that hydration matrix in place, we move right into chemical seasoning. We're going to add 1 tablespoon of Worcester sauce, and that's to provide the umami and glutamates that poultry just naturally lacks. Follow that up with a half teaspoon each of garlic powder and black pepper. Now pay attention, because here is a critical safety warning. Do not add salt to this interior meat. Seriously. We will explain exactly why later on, but for now, just consider it a totally unbreakable rule. Finally, you just want to gently fold these ingredients together. Don't overwork the meat. If you do, the protein fibers will cross-link and you're going to end up with a rubbery patty, which nobody wants.
Next up is our mechanical preparation. Step 1. You're going to form your patties about 20% wider than your naan buns. As you know, meat shrinks when cooked, and we really need the final patty to perfectly match that bun's diameter. Step 2 is basically physics in action, and we call it the dimple. You just press your thumb directly into the center of the patty. Why do we do this? Well, as collagen contracts under high heat, burgers naturally want to swell up into a sphere shape. The dimple forces the meat to cook perfectly flat, which guarantees maximum, even contact with our pizza buns later on. Finally, just sear them in a cast iron skillet over medium-high heat for about 5 to 6 minutes per side, until they hit a perfectly safe internal temp of 165 degrees Fahrenheit.
All right, let's jump to Phase 2, the non-matrix. This is all about building a load-bearing, waterproof crust.
You have to remember, moisture is the absolute ultimate enemy of this construction. When you're selecting your sauce, you must choose a really thick organic pizza sauce to maintain structural integrity. Please, whatever you do, do not use watery marinara. A watery marinara will actively dissolve your bread matrix. It'll basically turn your entire foundation into mush before you even get the chance to assemble the sandwich. So picking the right carb matrix materials is absolutely crucial here. We're going to need 8 mini whole grain naan breads, roughly 4 inches or so in diameter. We also need 1.5 cups of shredded, organic, low-moisture part-skin mozzarella. And let me just repeat a very similar warning to the sauce here. Do not use fresh mozzarella. The water content in fresh mozzarella will completely destroy the bread's integrity. Finally, grab 1 package of organic turkey pepperoni.
Let's look at the exact thermal processing we require here. First, you're going to lay the naan on a foil-lined baking sheet and apply exactly 1 tablespoon of that thick sauce to each one, making sure to leave a nice 1/4-inch border. Then, apply a micro layer of 2 to 3 tablespoons of mozzarella and top that with 4 to 5 slices of your turkey pepperoni. You bake all of this at 425 degrees Fahrenheit for about 6 to 8 minutes. You're looking for the cheese to be bubbling and the edges of the naan to be toasted and really rigid.
Now, what we've just achieved in the oven is culinary engineering at its absolute finest. We call it the lipid seal. By baking the cheese and sauce directly into the bread prior to assembly, we've essentially created a baked, rigid cheese layer. This acts as a literal hydrophobic barrier. Think of it like a waterproof shield that totally protects the naan from absorbing any of the hot burger's juices. It's a real game changer.
Okay, we're finally at Phase 3, Architectural Assembly. This is our final integration protocol. The orientation logic here is paramount. You cannot mess this up. First, the bottom bun. You place 1 pizza face up on the plate, so the toasted bottom of the naan is resting flat on the surface. Step 2 is a move we like to call the anchor. You take that piping hot turkey patty and place it directly onto the melted cheese of that bottom bun. The cooling cheese is going to act as a sort of culinary glue, anchoring the meat down and stopping any catastrophic slippage from happening. Finally, the top bun. Just place your second pizza face up, right on top of the patty. And yes, you heard that right, the pepperoni is fully exposed on the top.
Now, because you currently have a live, messy pizza surface acting as your top bun, we really have to issue a practical user manual tip here. You need to wrap parchment paper around the back half of the burger. This little handling hack ensures you maintain vertical stability while you're eating it, and honestly, most importantly, it keeps your hands entirely clean.
Section 5. Mitigating catastrophic structural failures. Defect resolution and safety. 1,500 milligrams. Let that sink in. That number represents the sodium overload defect. When you start stacking cured meats like pepperoni along with concentrated tomato sauce, cheese, and a burger patty, you can easily blast way past 1,500 milligrams of sodium in just a single serving, and that creates a literal cardiovascular hazard. So, how exactly do we correct these defects in our protocol? Well, for the sodium overload, remember our incredibly strict rule back in Phase 1? 0 added salt in the turkey patty. The salt from the pepperoni and the cheese is going to hit your palate on the very first bite, and it creates this amazing flavor halo effect that seasons the unsalted meat underneath perfectly. Next is the slippery slope defect. That's where your hot patty slides completely off the melted cheese. Our correction for this? You must omit all standard water-dense vegetables from the center stack, no exceptions.
Just to reinforce that last point, our protocol takes a very harsh stance on friction loss. It explicitly states, adding water-dense vegetables between the meat and the pizza bun removes friction and guarantees a blowout. So I'm sorry, but that means no lettuce, no tomato, no pickles inside the architecture itself. If you really want vegetables, they gotta be served separately as a side salad. We just cannot compromise the friction of that culinary glue.
Which brings us to the ultimate question, doesn't it? You now have the complete blueprint. You totally understand the physics of the hydration matrix, the absolute magic of the lipid seal, and the structural genius of the anchor. So are you ready to step into your own kitchen lab and engineer your own architectural pizza burger masterpiece? I highly encourage you to test this science out for yourself. Thank you so much for joining me for this explainer. And hey, happy engineering!